This is going on page 96 when we're done, okay? Focus up here. All right, so in part one, we solved trigonometric equations where the argument was a single variable, like x or theta. So the argument is what we're taking the sine, cosine, or tangent of, like sine of 2/3. 2/3 would be the argument. Oh, why this thing won't scroll? Okay. Now we'll solve trig equations where the argument is an expression with a variable, something like this. Okay. I chose not to add the ones that have the plus or minus in them on here. I think it's very unlikely that you would see one like that. You're way more likely to see like a 2x or a theta over 2 type of situation, but even that is a maybe. There's a lot of things that I can tell you, you will for sure see questions like this. You will for sure see questions like this. But then there's things that, I mean, they can't put everything on the test. So you will have trig equations, whether or not it will have, just a single argument or something with a number in it, who knows? It's just up for grabs either way. Okay, so the first thing we're going to do is we're going to look at this first circle, and I want you to go around and put in all of the angles in radians. You should be able to go all the way around the circle without my help. We've been doing this for a long time. I think this comes probably pretty easy for you. So go ahead and do that. And then where you put 0, if you didn't also add 2 pi, make sure you do that because we're going to talk about, move all the way around. That could be 0 or 2 pi. And we are experts at that by now, right? We can get that. We don't even have to think that hard, I hope. So that's if I make one rotation around the circle. After this first rotation, if I'm going to go again, then I would start at 2 pi instead of 0, and I will end at 4 pi. Okay? So basically, if I'm here at pi 6, so this is pi 6, if I think about it after a second rotation, I'm going to add 2 pi to that. Well, I don't want to have to, hang on a second, I got to rewrite that or I'm too close to the edge and it won't let me write. So we got pi 6 plus 2 pi. I don't know if that's any better. But when I add that, I don't want to have to think too much about fractions. But if we're thinking fractionally around the circle like we have, I know that the way we can know for sure we're at 11 pi 6 here is that 2 pi is 12 pi 6, and we back up 1, right? So for pi 6, I want to think about 2 pi as 12 pi 6. So if I take 12 pi 6, add it to pi 6, that gives me 13 pi 6, right? Then when I get to pi 4ths, for 2 pi, pi 4ths is 8 pi 4ths. So if I take pi 4ths plus 8 pi 4ths, I get 9 pi 4ths. You with me on that? Pi thirds, 2 pi would be 6 pi thirds. So pi thirds plus 6 pi thirds is 7 pi thirds. What's the question? Can you not read it or are you confused? To 1 pi 6, that gives me 13 pi 6. Okay. So then for fourths, this would be 8 pi fourths, right? So 8 pi fourths plus 1 pi fourth is 9 pi fourths. Okay? And then in thirds, it would be 6 pi thirds. 6 pi thirds plus 1 more would give me 7 pi thirds. Okay? So we got to think about, here, let's write them down. So we've got 2 pi, and that's the same thing as 12 pi 6, right? And that's the same thing as 8 pi fourths. It's the same thing as 6 pi thirds. And it's the same thing as 4 pi halves, right? So we're thinking fractionally that way to be able to add them. Does that help? Okay. Everybody good now? Okay. So then when I get to pi halves, at pi halves, I'm going to add 4 pi halves. That gives me 5 pi halves. Right? So then when I get to 2 pi thirds, what am I going to add to 2 pi thirds? 6 pi thirds, right? Because it's the thirds. So that gives me 8 pi thirds. Okay, you do the next 3 to make sure we're all on the same page here, and then I'll turn you loose on the rest. Just make sure you understand what to do on the next 2. Okay, so this is 3 pi fourths. I need to add 2 pi. That's 8 pi fourths. That would give me 11 pi fourths. And then this, with 1 rotation, is 5 pi sixths. I add the 2 pi, which means I'm adding 12 pi sixths. So that is 17 pi sixths. And then if this was 0, this was pi, this is 2 pi, this is going to be 3 pi. Everybody good? Okay, so finish up the circle. You got this. Bless you. Bless you. It's the prettiest sneeze. Very dainty sneeze. Okay. So, do you understand how we're getting these numbers? So, here's the deal. You're not, I mean, yes, I know we've written out this circle like a bazillion times. That was to make sure we could learn it, and we got it now, and that's piece of cake. You're not going to have to write out that circle a ton of times, but we are going to have to come up with some of these values. And so I wanted to make sure you understood how to add them, still thinking fractionally just like we had. Let's say I had to go around again, right? So on a third rotation, then if I'm here at 7 pi thirds and I go around again, to that I'm going to add another 6 pi thirds, and I'd end up with 13 pi thirds, right? I can just add a 6 pi thirds for every rotation. You don't have to overthink your fractions. You kind of already know what your fractions would be. Okay, are we good? All right, so let's look at how to solve these. We're going to start with, and so it says find all the solutions, and it does say all, so it means we're going to have that infinite thing going on. The difference here in what we have, let's just go ahead and rewrite it. Cosine of 2x equals negative square root of 2 over 2. Okay, so the difference in this and what we've been doing the last couple of days is this says 2x instead of just x. So when it was just x or just theta, we would look at this and say, what angle gives me the cosine value of the square root of 2 over 2? We are going to start off doing the exact same thing. So here is my little thing, and I've got negative, cosine's negative in which quadrants? Second and third. Okay, so it's negative in these two quadrants. Now I'm going to have not x equals. Whatever's inside of here, like what angle gives me this, but this is the angle. So instead of x, I'm putting 2x is equal to, all right, what first quadrant angle gives me a cosine value of the square root of 2 over 2? Pi fourths. Okay, so I don't want the first quadrant. What is my second quadrant pi fourths angle? 3 pi fourths. All right. And since I want all of them, I have to add what? 2 pi k, right? Because 2 pi is the period. That gives me all the angles that would land right there without me having to add them like we just did. But then I also have to take care of the third quadrant. So 2x is equal to what? What's my third quadrant pi fourths angle? 5 pi fourths. Very good. And then I put again plus 2 pi k. Everybody with me so far? So this is, if this just said x and not 2x, we'd be done. And that's where we've been going the last couple of days, right? But I don't care about 2x. I want x. So I need to multiply both of these by 1/2. So when I do that, 1/2 times 2x is x. 3 pi fourths times 1/2 is 3 pi eighths. Plus 2 pi times 1/2 is pi times k. You don't have to know where 3 pi eighths is on the circle or anything. You just have to be able to get that answer, and then you're good. So on this one, I've got x equals, this will be 5 pi eighths plus pi times k. So really just one more step there. What questions do you have? We good? All right. So then let's just rewrite this. Sine of x over 2 is equal to 1/2. Right. Sine is positive in which quadrants? First and second. Right. So you take whatever the angle is, whatever the argument is, and that's x over 2. That's equal to, all right, what angle gives me a sine value of 1/2? Pi 6, okay? So I'm at pi 6 plus what? 2 pi k. Yes. And then x over 2 equals, what's my second quadrant angle? 5 pi 6 plus 2 pi k. I don't care about x over 2. I want x. So what am I going to multiply these by? 2. So I'm going to get x equals pi 6 times 2 is like 2 pi 6, which is pi thirds, plus 2 pi times 2 is 4 pi times k. And then x equals 5 pi thirds plus 4 pi k. What questions do you have? Mm-hmm. Yes. I can't scroll. Yes. Yes. Okay, there. I'm sorry. I was trying to scroll so I could look at that. So you're just doing whatever you have to do to get this to be x. So since this is 2x, I'm multiplying by 1/2. Since this is x over 2, I'm multiplying by 2 so that those will cancel out. That's how I make my decision. Okay. Anything else? All right, so, and the reason, remember, that we are doing plus 2 pi k is because 2 pi is the period for sine and cosine, right? That'll give you however many rotations, give you another full rotation around. All right. Example 3. Let's rewrite this. Tangent of 3x equals the square root of 3. What quadrants is tangent positive in? First and third, right? So I take whatever that argument is, 3x, set it equal to what angle gives me a tangent value of the square root of 3? Pi thirds, exactly. All right, so before we write anything else, remember, for tangent, I'm not writing 2 pi k. The period for tangent is what? Pi. So just this angle is enough, because if I add pi, I end up here, and then I add pi and I end up here, and it ends up taking care of those angles right there. So this is really plus pi times k. And I don't have to do the other one because that takes care of it. Now, there were some people on the other assignment where we did this that had written out pi thirds plus 2 pi k and 4 pi thirds plus 2 pi k, or something like that, which is not wrong. Like, those are correct values. I wouldn't necessarily count it wrong if you had to write it out. College Board wouldn't count it wrong because they are correct values and you take care of everything. However, this is way more likely to be a multiple choice question, and it will not be written that way. It will be written this way. So I want you to get used to that so you're not confused, okay? Because, I mean, if you still have a correct value, yeah, there's different ways to write it, but like, this is how we would write it for tangent, okay? Everybody good with that? And then I only have one that I'm writing there. But I don't want 3x, I want x, so what do I multiply it by? 1/3, okay? Multiply it by 1/3, and I'm gonna get x equals pi ninths plus pi thirds times k. I had the question earlier, could we write it as 1/3 pi times k? Again, it's not wrong, but you would never see it that way because these are angle measures and we always write them as one fraction. So we want to get used to writing it like we're going to see it and like properly, okay? What questions do you have? All right, so this is when I have an infinite amount of answers. What happens when we have an interval that we are narrowed down to, 0 to 2 pi? Okay. When that happens, we are going to take care of the interval first. Okay, so since it's not written every time, I want you to go ahead and write it out again. 0 is less than or equal to x, which is less than 2 pi. Then I need whatever the argument is, that is 2x. That is what needs to be over there, not just x. So I need to multiply this whole thing by 2. And when I do that, I get 0 is less than or equal to 2x, which is less than 4 pi. Okay, so it changes my interval. And since I'm going to 4 pi, that means I have 2 rotations. That's the information I need from that. How many rotations do I have? Okay. All right, so now that I've taken care of that, I know what my interval is. Then I'm going to come back over here. I'm going to solve this. So I'm going to divide both sides by the square root of 2. Those cancel out. That's not normally how I see my numbers, so I need to rationalize the denominator. And that gives me square root of 2 over 2. So that means I have the sine of 2x equals square root of 2 over 2. Okay, and I'm back where basically what they gave me on the other side. Sine is positive in which quadrants? First and second. Okay, So I'm going to have 2x equals, and then what angle gives me a sine value of square root of 2 over 2? Pi fourths. And then my second quadrant pi fourths angle is 3 pi fourths. But then I'm not done because I need to make 2 rotations. So I did pi fourths, 3 pi fourths. I rotate around again. I'm back here where pi fourths lives, but I got to add 2 pi to that. So I'm going to add 8 pi fourths, and that gives me what? 9 pi fourths. Then this is where 3 pi fourths lives, but I got to add 8 pi fourths to him, and that gives me 11 pi fourths. Okay? You with me so far? So notes plus 2 pi k, but I could have more than 2, just because it depends on how many rotations I have. But just like the other side, I don't care about 2x. I want x. What am I going to multiply this by? 1/2. And when I do that, I get that x equals pi eighths, 3 pi eighths, 9 pi eighths, and 11 pi eighths. Okay. What questions do you have? Anything? All right. So then here, let's write down our interval again. We're going from 0 x to 2 pi. All right. But I need it to be x over 2, so I need to multiply this by 1/2. So it's going to give me 0 is less than or equal to, x over 2, which is less than pi. So here I'm only going from 0 to pi, so that gives me half a rotation. We'll deal with that when we get there. Okay? All right. So I'm going to take this. I'm going to divide both sides by 2 square roots of 3. Those cancel out. On the right-hand side, I have a square root in the denominator, so I need to rationalize. So that gives me 3 square roots of 3 over 6. And then can I reduce that? Yes, and I get square root of 3 over 2. Okay. So that gives me cosine of x over 2 is equal to square root of 3 over 2. You think I could just right here go ahead and like multiply both sides by 2 and get rid of the 2's in here and here? No, because that's on the inside, so that's totally illegal. Okay, cosine is positive in which quadrants? First and fourth, right? But I'm only doing half a rotation. That means I am only going from 0 to pi, so the bottom part of this doesn't even count. Okay? So I'm just going to mark it out so I don't do anything wrong. So that means I'm going to get one number out of this. And x over 2 equals, all right, what angle gives me a cosine value, the square root of 3 over 2? Pi 6. And that's the only one I get because of the rotations. I don't care about x over 2. I want x. So I multiply this by what? 2. So I get x equals pi thirds. And that's my answer. Okay. What questions we got? Nothing? We okay with where everything came from? All right. Next one here, we've got the same intervals, so I've got, let's write it out again. And then I guess I need to go ahead and set this up so I know what to do with that. I'm given g of x, and I want the zeros. So tangent of 4x is equal to 0. So my interval over here, I need that x to be a 4x, so I got to multiply by 4. It's going from 0 to 8 pi. How many rotations is that? 4, right? Because if I go 2 pi each time, I got 4 rotations. So this is 4 rotations. All right. So over here, tangent, so this will give me 4x equals, that's a quadrantal, right? So when does what angle gives me a tangent value of 0? 0 and what? Pi. So I've got 0 and pi. But that's 1 rotation. So I got to keep going. So write out your 4 rotations. I bet you can think your way through this just fine. Okay, because if I'm here, this is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. And I don't get to use 8 pi, right? Because that's not included. It's just, I just add the pi's. That was way easier than adding the fractions, right? But once again, I don't care about 4x. I want x. What do I multiply this by? 1/4. So write out your new numbers. You can do it without me. All right, and I think this is a good example to talk about our intervals a little bit more. We know it tells me that I'm supposed to give my answer from 0 to 2 pi. Then it looks like I magically just get to decide to change it, right? But I change it by multiplying by 4, but then I turn around and I divide everything out by 4. So really what that is doing is helping me get enough answers written down. Because if you look at what our answers actually are now, I have 0, pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, and 7 pi fourths. My actual answers are only going from 0 to 2 pi. So because we're multiplying and then we turn around and divide it back out in a different way, we're still just getting answers between 0 and 2 pi. But if we don't do this in the beginning and figure out how many rotations, we may not end up with enough answers written out. Okay, so that just kind of helps you get enough of them there. Okay. What questions you got? Anything? All right. Last one then. All right, so once again, I've got 0 to 2 pi, so I'm going to write that down first because we don't want to forget to deal with it. Then we've got sine squared of 2x, and g of x is 1. In the xy plane, what are the x coordinates of the points of intersection for f and g? What do I do to set something up? Put them equal to each other. Good. So I'm going to have sine squared of 2x equals 1. Now, there's more than one way to work this out. We'll talk about both ways, but I think most of you probably would just go from here, which is fine. Is it legal to take the square root of both sides here? Yes, this one's fine because I got the sine squared equals a number. That is totally legal. Okay, and what probably most of you would do, we'll talk about the other in just a second, but I'm going to take the square root of both sides. So that leaves me with sine of 2x. And by the way, if the argument had an x squared on it, it would not take the square off of that. It's the sine squared that we're taking the square root of. And that equals, since I introduced the square root, what do I have to put? Plus or minus, okay? And if you are still making that mistake and not doing that, I honestly don't know how to help you. I say it as many times as I possibly can, and we cannot mess that up. So another way to do this is a quadratic. I could set it equal to 0, and then I would have a difference of squares. And then if I factor it, I wouldn't miss my plus or minus. But as many times as I've taught this stuff and tried to teach everybody to do that way, y'all still seem to get to here and take the square root of both sides. And as long as you're doing that legally, it's totally fine, because it's a way to solve it. It's fine. Okay, so sine. When I find the angle, this is going to give me 2x equals, all right, what angle? Oh, what did I forget to finish? My interval over there. Yep, see, it's about to. I meant to set it up and come over here, and I got distracted by the squared. But that's a 2x, so I got to multiply this by 2. And this is 4 pi, so how many rotations is that? 2. 2 rotations. Okay. So what angle gives me a sine value of a positive 1? Pi halves, right? And what gives me a value of negative 1? 3 pi halves, okay? So that is 1 rotation. The next time I get to pi halves, what's that measure? 5 pi halves. And the next time I get to 3 pi halves, I'm at 7 pi halves. Everybody with me? I don't care about 2x. I want x. What do I multiply this by? 1/2. Very good. So then go ahead and write out your answers. If you could solve the other equations we were solving, you can do these. You just have to pay attention that if your argument is not just x or theta or some other single variable, that you take care of your interval there. Okay? What questions you got? Anything? All right, awesome.